How did Archimedes discover the 1-3 cone volume factor? Imagine trying to figure out how much space a cone takes up without fancy tools or computers. Long ago, one brilliant mathematician used clever ideas to solve this puzzle. Archimedes looked at shapes like cylinders and cones and wondered how their sizes compared. He knew a cylinder with a circular base and a certain height was a simple shape to measure. Then he thought about a cone with the same base and height. How much space does it fill? Archimedes sliced these shapes into very thin horizontal discs. The cylinder's slices were all the same size because its sides are straight up and down. But the cone slices got smaller as they went up because its sides slant inward. He noticed that the area of each slice in the cone was smaller in a specific way compared to the cylinder. The slices of the cone got smaller in proportion to their height, decreasing linearly from the base to the tip. He then compared the total volume of the cone to the cylinder by imagining stacking all these slices. The key was understanding that the sum of the cone slices added up to only 1/3 of the total volume of the cylinder with the same base and height. This was a big discovery because it showed a simple relationship between these shapes. Archimedes also used a balancing trick. He imagined the cone and the cylinder as weights on a lever. To keep the lever balanced, the cone's weight had to be 1/3 of the cylinder's weight. This physical idea helped him see why the volume of a cone is exactly 1/3 of the volume of a cylinder with the same base and height. From this, he derived the formula for the volume of a cone. It is 1/3 times the area of the base times the height. If the base is a circle with radius r, then the volume is 1/3 times pi times r squared times h. This discovery was so important because it showed how slicing shapes into tiny parts could reveal their true size. It also laid the groundwork for the idea of adding up many small slices to find the total volume, which is a core idea in calculus. So, Archimedes' clever slicing and balancing methods helped him understand that a cone's volume is 1/3 of a cylinder's volume with the same base and height. This simple yet powerful idea changed how we think about three-dimensional shapes forever.